All right, in the last video, we did an example of exponential growth where we had this petri dish with 2,100 bacteria cells. That's where it began. But then every hour, it increased by 7.4%. And so we wrote our equation like that. We had to use y and t. For number 5, it's a similar question. Let's read it. It says there was a sample of 450 milligrams of some radioactive substance to start. Since then, the sample has decayed or decreased by 6.8% each year, so a constant rate of decrease. Let t be the number of years and let y be the mass of the sample. I want to write an exponential function showing the relationship between the two. So again, in order to write an exponential function is f of x equals a b to the x. A is the initial, b is the constant rate of change, if you will. So in this case, A is going to be the initial amount of 450, right? That's what it says. All right. Since then, the sample has decayed 6.8%. So for B, I want to show that it decayed 6.8%. That means that whatever it started with, 100, you decreased it by, remember, 6.8% is 0.068. Minus the 0.068, right? And if you do that math, I'm going to take out a quick little calculator here just to make sure I get it right on the first try. If we do 1 minus 0.068, we get 932. So 0.932. That's our B. This shows a decrease of this rate. And so if I were to start writing my equation, I would say that f of x is equal to a, or 450, times b, which we found is 0.932 to the x. Now again, we don't want to use f of x and x. We wanted to use y, keep the numbers the same, and then the time t. So that's what I'm going to plug in over here into Alex. And unless I did something wrong with the subtraction, we should be good. So y is going to equal 450 times 0.932 x. Oh, didn't want x, sorry, to the t. That's what it says here. I wrote x. We should be good. And then number 6 is similar. Let's just see. Oh, it says population has grown by 8.7%. So it started with 230. It's grown 8.7%. Let t be the number of years since the start. Let y be the population. Ooh, I can do this one kind of straightforward. Y is going to equal whatever our starting amount is, 230,000. We're going to multiply that by, in this case, a growth. It's 1.087 because 8.7% is 0.087. But I grew it, so I'm going to add it to 1, and then I'm going to raise that to the t, to the time value. All right, so looking at this and writing exponential functions from word problems, not that big of a deal, as long as you understand how to write a general exponential function. All right.